If you recall from the last video, I mentioned but did not discuss a primitive data type called booleans. Before we can move on, we need to understand this useful data type. Booleans represent one bit of information. They have two possible values, true or false. To declare a Boolean value, we use the Boolean keyword in front of the variable's name. We can then assign it a value of true or false by typing the true or false keyword on the right side of the assignment operator. Booleans are typically used in logical expressions to check if certain events have occurred or if certain conditions have been met. For this reason, they are colloquially termed flags by computer programmers. How do we use Booleans and other variables in this way? First, we will need to understand a handful of new operators called relational and logical operators. There are 9 total. The equals equals operator is a binary operator that checks to see if its operands are equal. The not equals binary operator checks to see if its operands are not equal. The less than equals binary operator checks to see if the left operand is less than or equal to the right operand. The greater than equals binary operator checks to see if the left operand is greater than or equal to the right operand. The less than binary operator checks to see if the left operand is less than the right operand. The greater than binary operator checks to see if the left operand is greater than the right operand. The not operator is a unary operator meant for use with Booleans. It inverts the value of the Boolean or Boolean expression it is paired with. The logical and binary operator takes two Boolean expressions as its operands. If both operands evaluate to true, then the entire expression evaluates to true. The logical or binary operator takes two Boolean expressions as its operands. If at least one operand evaluates to true, then the entire expression evaluates to true. Now that we understand these different logical operators, we need to be able to use them. Java has many structures in which they can be used, but for now, we will look at the if statement, or if block, and the switch statement, or switch block. Let's look at the if statement first. The if statement consists of an if clause, declared with the if keyword, and an else clause, declared with the else keyword. The if clause checks to see if the condition in parentheses evaluates to true. If so, any code inside the if clause will be executed, and then we'll leave the if loop entirely. Otherwise, that code is skipped altogether, and the code inside the else clause is executed instead. Sometimes it is necessary to declare one if statement inside another. This is called nesting. Nesting can be done either in the if clause, like this, or in the else clause, like this. Typically, however, this is simplified by having the if clause evaluate two conditions at the same time, like this, or by adding an else if clause, like this. The else if clause functions the exact same way as the if clause. If the condition in these parentheses evaluates to true, then the code inside the else if clause is executed. Otherwise, it will move on and evaluate the next expression, or if there are no more expressions to evaluate, it will drop down into the else clause and execute the code there, and then leave the if statement entirely. While we can only have one if clause and one else clause per if statement, we can have as many else if clauses as we want. It's best to try and minimize this, though, for the purposes of debugging, efficiency, and readability. Let's try running our if statement with the current example. As you can see, the first statement was printed out. That's because anum less than 10 evaluates to true, and num not equal to 3 also evaluates to true. Since they both evaluate to true, this entire expression evaluates to true. Thus, that statement is printed out. Feel free to experiment with the operators to learn more about how they work. You can use my code and simply input different operators where my operators are, or you can use your own code. Another way to execute code based on the values of variables is the switch statement or the switch block. This statement is declared using the switch keyword, followed by the variable that we want to check in parentheses. Then it uses cases to test the value of the variable. If the test value matches the value in the variable, then the code within the case block is executed. Each case block ends with a special keyword called break. This keyword tells the program to leave the switch block entirely. This is useful since we don't need to continue with the statement once we have a matching case. If the break keyword is not there, fall-through would occur. That is, the statement would continue to execute starting from the matching case block and ending when it either encounters a break statement or reaches the end of the switch block. The last case of the switch block has a special keyword, default. This is a special case whose code will execute should no other case match the value of the variable we are checking. Let's take a look at an example with our switch statement. In this example, we have a variable, number, equal to 2. We then pass number to the switch statement to check its value. We have 3 cases and a default case. Let's run the program and see what happens. It printed out the value as 2. That's because, as it went through the cases, none of them matched until it got to case 2. Let's try changing the value. As you can see, the matching case is the statement that's printed out. The break statement keeps it from falling through and printing out all of the other statements. In many cases, the switch statement can be simplified to a string of if-else statements. So how do we know which one of these two to use? The if statement has one major advantage over the switch statement. It is capable of checking for a range of values as well as a single value. The switch statement can only check for single values. Thus, if you need to check for a range of values, the if statement is a better choice. If you only need to check for individual values, then the switch statement is a better choice for purposes of readability and debugging. If you're ready to move on, please proceed to the next video. Otherwise, you may restart this video at the location of your choosing.